We're in section 9.2. We're still doing hypothesis tests, but now we're going to focus on proportions and how to go through the calculations of a hypothesis test. So a couple of pieces of advice before we get started. Rubrics for the AP exam typically require a test statistic in addition to the p-value. So whether you do all your calculations by hand or if you do them in a calculator following what I showed you or what was shown to you in the technology corner, make sure that you write down both the test statistic and the p-value and show work that is going along with it. You have to name a test or give the formulas that go along with your test. All calculations are done assuming the null is true. Remember, we're assuming the innocence until we prove guilty. So in this, we're going to assume the null is true. We're going to do our calculations based on the null until we're able to find, or hoping we're able to find, evidence against it and in favor of our alternative hypothesis. So now to get to number 40, we're going to look at that problem. Rearrange a few things so we can see them better. So a drug manufacturer claims that less than 10% of patients who take its new drug for treating Alzheimer's disease will experience nausea. To test this claim, researchers conduct an experiment. They give the new drug to a random sample of 300 out of 5,000 Alzheimer's patients, whose families have given informed consent for the patients to participate in the study. In all, 25 of the subjects experienced nausea. Use these data to perform a test of the drug manufacturer's claim at the alpha equal 0.05 significance level. We're always going to start with our null and alternative hypotheses. Remember, our null hypothesis is always a statement of equality. Since we're dealing with proportions, we're going to have proportion is equal to. And then in our alternative hypothesis, that's where we're doing an inequality. So we're claiming that it's less than 10%. Since that's what we're trying to build evidence for, we're going to make that our alternative hypothesis. So the proportion is less than 10%. Which means our null hypothesis would be that it's equal to 10%. So our parameter of interest that we're using here is P is the true proportion of patients who experience nausea or who would experience, since we want this to be all patients, who would experience nausea on this drug. And we were given an alpha of 0.05. Our p hat that we're being given is 25 out of the 300, which if we put that into our calculator, we get 0.083 repeating. So we're going to use this information to go on with our test. Now first, before we do any calculations, we would have to check our conditions. So we know that we have an SRS of 300 patients. In checking our 10% condition, we know that 300 is less than 10% of 5,000. And in checking our large counts condition, we know that N of 300 times P of 0.1 is equal to 30, and N of 300 times 1 minus P of 0.9 is equal to 270, and both of these are greater than or equal to 10. That means that we will be using a one proportion z-test. So now everything that we need is right here in our answer, and we're going to go on with our calculations using this information that we've set up. So first we're going to need to find our z-score. Our z-score that we're going to use is just like the z-score that we've been using before. In this case, our observation would be our p hat, and our p hat was 0.083. Now when you did this calculation before in your calculator, make sure it's saved in there so then we can just use second answer and get the most precise value as possible. Minus, we're going to use the p that we got in our null hypothesis, so 0.10, divided by the standard deviation, which is the square root of 0.10 times 0.90 over n is 300. And if we put all of that into our calculator, we get negative 0.962. Now, if we take that z-score and go to our resource packet, negative 0.962 would be negative 0.96, oh, sorry, you can't see that. Negative 0.96, when I move over here, I get 0.1685, so that is our p-value. Now that p-value would be greater than our alpha level of 0.05. Since it's greater than our p-value is high, we will fail to reject. And then giving our conclusion and context, we say that we do not have statistically significant evidence that the true proportion of patients who would experience nausea on this drug is less than 10%. So that would be all of our work for the problem, walking through our 4-step process. Thank you.